Kia ora koutou. This is an excellent question from the 2020 paper. I'm making it sitting in the kitchen with dinner cooking, so I'm hoping the background noise is okay. I really like this question because it tests whether you understand the difference between the area under a curve and the integral in the same limits. So what we've got here is we've got a curve, and the curve is quite an easy one. The curve is y equals x plus 2x to the half minus 3. So we know that's going to be easy to integrate. And we can see that we've got the area, and this bit here is below the curve, right? And this bit here is above the curve. We have to find the shaded area. So that means that what I want to get is I need to get a positive area number for here, and I need to get a positive area number for here. The problem is that when I integrate, if I integrate the limits of the function between 1 and 0, that number is going to come out as negative blah, blah, blah. So to find the area, I have to figure out what that point is there. So I guess I've just ruined it. That point there turns out to be 1, but we have to go and work that out first. The total area is going to be made up of these two integrals. It's going to be the absolute value of the integral between 1 and 0. And then it's just going to be the integral between 4 and 1. And once you think about the question like that, it's pretty clear what you've got to do. But the first step we've got to do, now that I've given it away, is we have to figure out where this is equal to 0. So let's do that first. So y is equal to x plus 2 root x minus 3. Now this is just a little disguised quadratic from level 2. I'm hoping that a lot of you will be able to factorize that straight away. But if you can't, you can rewrite it as y equals u squared plus 2u minus 3. And that is one that factorizes really nicely. So we get u plus 3 and u minus 1. And that gives me, to solve where that's equal to 0, u is equal to 1 or negative 3, but u is the square root of x. And so if it's got to be real, then that's not valid. So we just get our one solution, that root x equals 1. So up here we were saying let root x equal u. And in some ways that's the trickiest bit of this question if you are confident with this idea here, that you've got to split up areas into bits above and below the curve. If you just do this and you instead forget about that and you just do this integral, you're going to come out with a number that's too low because it's going to end up with a whole lot of negative stuff there. Okay, so we've got to split it up. So now it's a little bit painful, but we can work it out. So the total area will be the absolute value of the integral between 1 and 0 of this. So put this into fractional powers, plus the integral between 4 and 1 of the same thing. Now, integrating, what do we get? Well, here we get a half x squared plus 2 times 2/3 of x to the 3 over 2 minus 3x, evaluated there. And we want to have the absolute value signs around. Plus the same thing again, a half x squared plus 4/3 of x to the 3 over 2 minus 3x between 4 and 1. All we have to do now is to work it out without screwing it up. So let's see how we go with that. Right, so we want the absolute value of 1/2 plus 4/3 minus 3 minus, this will be 0, this will be 0, and this will be 0. So that's good. And here we're going to have, what are we going to have? Well, 4 squared is 16. So a half of 16 will be 8. So 16 over 2 plus 4/3. Right, let's look at this without our calculators. So x to the power of 3 over 2 means the square root of x, which will be 2, cubed. So that will be 4/3 of 8 minus 12 minus the bottom end of the integral at 1, but we've already worked that out there. So looking at what we've got here, so it's going to be minus 12, 1/2 plus 4/3 minus 3. We've just got to clean up a whole bunch of fractions. And something weird just happened to OneNote. Okay, hopefully it's going to come back to the same place. Nearly. Right. Okay. So just going back to the integral, all we've got to do is collect up our fractions. I know some of you guys are going to use your fraction buttons on your calculator. I can't cope with that. So we've got 3 over 6 plus 8 over 6 minus 18 over 6 plus 8 plus 32 over 3 minus 12 minus this thing here. Let's have a look. So this is negative 7 over 6. So it's minus negative 7 over 6. But this has got to have the absolute value sign around it, right? Because we want the area, not the integral. So the area is 7/6 plus this gives me what? What do we get here? Well, negative 4. So this gives me plus 20 over 3 plus 7 over 6. And when I work all of that through to a common denominator, I get 7/3 plus 20/3, which is a very nice round number, which gives us 9. Okay, so just really quickly, big idea in here again is that the area when the curve is below the x-axis is not the same as the integral, right? We have to find the integral and then take the negative of that negative number. Thanks for watching. I will do question 1e probably later on tonight or tomorrow.